Okay, so we are going to be looking at two different sections. We're looking at 18.1, which is multiplying polynomial expressions by a monomial. And then we're also looking at 18.2, which is multiplying polynomial expressions. So we're combining these because they're essentially the same thing. It's just kind of building off of one topic. So we're going to start with multiplying by monomials. So you can see that it first says remember. So this is just a little reminder of how we multiply when we have a number on the outside of parentheses. I think we all know that we would need to distribute that. So this would end up as 2x plus 4. So we'll be using that throughout this lesson. So we'll first start off with multiplying monomials. So we can see that we have 6x cubed times negative 4x to the fourth. I'm going to just rewrite this. We really don't need the parentheses, so I'm just writing it as a multiplication problem. Now, this section is essentially a repeat of when we did exponents, right? We've already kind of done this. So we would just multiply our numbers. So we have 6 times negative 4, which is negative 24. And then we have x cubed and x to the fourth. So remember, when we multiply exponents, we really add them. So this would become x to the seventh. So our final answer would be negative 24x to the seventh. All right, for our next one, so first step is just to rewrite it without the parentheses. So we have 5xy squared times 7xy. So I'll multiply the numbers first. So 5 times 7 would be 35. And then you'll multiply the like terms. So we have an x and an x. So really that's x to the first and x to the first. So that would become x squared. We have y squared and technically y to the first, which would become y cubed. So our final answer would be 35x squared y cubed. All right, this next one will be done on your own, so you could take a look at the notes PDF to get the answer. So now we are going to look at multiplying a monomial by a polynomial. So this is, now we have the monomial and then we have to multiply it by multiple terms. That's really the difference. So we are going to use the distributive property. So just kind of like how we practiced at the beginning. So I take my 3x and I'm going to distribute it to each part. And again, we've kind of already done this when we studied exponents. So it's nothing new. It's just remembering those exponent properties. So we're doing 3x times 3x squared, and we'll kind of do this one at a time. So 3x times 3x squared would be 9, and then x cubed, because 3 times 3 is 9, and then x times x squared would be x cubed. Then we're going to do 3x times 6x. So we would do 3 times 6, which is 18, and x times x, which is x squared. Then we'll do 3x times negative 5. So that would just be negative 15x. Then we just want to see if there's anything that we can combine, and there's not, and it's already in standard form because it's from the highest degree to the lowest degree. All right, looking at the next one. So we're going to use distributive property again. So we will distribute the first one. So we have 2 times 2xy times 5x squared y. So we'll do the 2 times 5, which is 10. We have x times x squared, which would be x cubed, and y times y, which would be y squared. Then we'll do that times the next term. So we'll do 2 times 3, which would be 6, and then x times x, which would be x squared, and y times y squared, which would be y cubed. And then lastly, we have 2xy times 7xy. So you'll do 2 times 7, which is 14, and then x times x, which is x squared, and y times y, which is y squared. So we just want to make sure that this is in standard form. So it looks like the first term has a degree of 5, and so does the second. and then the third one has a degree of 4. So as far as like ordering whether we put the 10 or the 6, so we actually are going to leave it as is because the exponent for the x is higher in the first one than the second. Now, we're not going to get too particular on that kind of thing, but we do want to make sure that both the 10 and the 6 are in front of the 14 because that has a degree of 4. Okay, so the your turn, again, you guys will try that one on your own. So that was it for section 18.1. So now we're going to go into section 18.2. So all that is different about this is now we're going to be doing polynomials times polynomials. So we're going to be looking at 3 different methods. So the nice thing is this will give you guys options, but once we have these 3 different methods, you will get to pick which one is easiest for you. So the first method is the distributive property. This is probably going to be the one a lot of you use just because it feels familiar, but we'll see. So what we're going to do first is we have our x, and I want to multiply, I got to distribute to the other part. So we would get x times x, which would be x squared. Okay, then I also have to distribute that x to the 2. So x times 2 would be 2x. But that's only distributing the x, so I have to do the same thing with the 5. So we do 5 times x, which would be 5x, and 5 times 2, which would be 10. So now I have x squared plus 2x plus 5x plus 10, and we could actually combine those middle terms. So this would turn into x squared plus 7x plus 10. And that would be our final answer. So that is the distributive property. There's one more example, but that's a your turn problem, so you guys can try on your own and check with the notes. All right, so our second method is the FOIL method, and a lot of you guys probably use this in biology when you are doing like Punnett squares and stuff, which is kind of also like the next method. So the FOIL method, the only thing about it is that it only works for a binomial by a binomial. So remember, a binomial is 2 terms. So it only works for a 2-term by a 2-term. So I'll just say 2 by 2. So it will not work otherwise. So what does FOIL method mean and what does it stand for? So it's an acronym. So FOIL stands for the first, then the outer, then the inner, and then the last. And this will make a little bit more sense once we go ahead and look at an example. So our first example is 3x squared minus 2x times x plus 5. So I'm going to be doing a lot of like erasing just because it's easier to show when I underline things. So what it's saying is multiply the first terms. So this is a first term and this is a first term. So when I multiply those together, I would have 3x squared times x. So that would be 3, and then the x squared times x would be x cubed. Okay, the O is for the outer terms. So this is an outer term and this is an outer term. So the outside terms. So 3x squared times 5 would be 15, because 3 times 5 is 15, and then we would just have the x squared. The I stands for the inner terms, so we look at the insides. So that would be negative 2x and x, so that would turn into negative 2x squared. And then the L stands for last, so we're looking at the last terms. So that would be negative 2x and 5. So that would turn into negative 10x. Now looking at all of this, it's just kind of in a like vertical formation, but what we want to do is see if there's anything that we can combine, and we can combine those 2 terms. So our final answer would be 3x cubed, and then 15x squared minus 2x squared would be 13x squared, and then we would just have negative 10x. And that would be your final answer. And then the next problem you will do on your own and check the answers. And then our last method is the box method. And I actually take it back. I think most students actually use this even over distributive property, especially if you're a more visual learner. I personally like this method just because it's a way to kind of organize your math. So the box method is like what it sounds. You're going to make a box, or a rectangle rather. So we have x plus 2 times x squared minus 5x plus 4. So what you want to do is like determine the size of those. So the first polynomial is 2 terms and the second one is 3. So what I'm going to do is make a 2 by 3 rectangle. So that will be your first step. So a 2 by 3 rectangle. Now on the side with 2, I'll put the x plus 2. And on the side with 3, I'll put the x squared minus 5x plus 4. Now this gets a little bit confusing if you're not familiar with these rectangle models, but once you get the hang of it, it becomes very easy. So what we're doing is we're kind of finding like the area of each rectangle. So if we're looking at this one, we are going to multiply x times x squared, and that would give us x cubed. Now when we look at this one, the top, so technically the dimension would be 2 times x squared. So that would be 2x squared. For the next one, it would be negative 5x times the side length of x. So that would be negative 5x squared. The next one would be negative 5x times 2, which would be negative 10x. The next one would be 4 times x, which is 4x. And lastly, 4 times 2, which is 8. So now we have all of these terms in this polynomial. And now we could either write it all out, so as each separate terms, but it's also kind of nice the way it's organized, because if you look at the diagonals, they are like terms, so we can just combine it as we write it. So the first term would be x cubed, and then we have 2x squared and negative 5x squared. So if we have 2x squared and we take away 5, we would have negative 3x squared. And then we have negative 10 x's and we add 4. So then we'll have negative 6 x's. And then we just have our positive 8. And that would be your answer. So these are 3 different methods that we can use to multiply. This last one is going to be on your own. But when you set it up, keep in mind that this one's actually a 3 by 3 because it's 3 terms by 3 terms. So that is everything you need to know about multiplying polynomials.